in mathematics, it is frequently important to recognize patterns to discover relationships. One of the most important and well-known theorems in mathematics usually comes to you in geometry in high school, and it's called the Pythagorean theorem. And a set of numbers is called a Pythagorean triple, provided that the square of the two smaller numbers adds up to the same as the square of the larger numbers. The most famous of these Pythagorean triples is probably 3, 4, 5, because 3 squared is 9 and 4 squared is 16. 9 plus 16 is 25, and guess what? That's 5 squared. Notice that 3 plus 4 is not equal to 5. Aha. Well, it turns out if you double 3, 4, and 5, you get 6, 8, 10. You have another Pythagorean triple, and 6 and 8 squared are 36 plus 64, and that totals 100, which is 10 squared. And so on. If you multiply 3, 4, 5 by 3, you get 9, 12, 15, and that's another Pythagorean triple. Another famous one is 5, 12, 13. 5 squared is 25, 12 squared is 144, 13 squared is 169, and that's 25 plus 144. And if you double that to 10, 5 goes to 10, 12 goes to 24, 13 should go to 26, and it does absolutely work. And it continues to do that as long as you have a multiplier. 8, 15, 17 is another Pythagorean triple, and there's an infinite number of them, and one of my favorite topics. Now, pattern recognition. This is going to be about 3 different variables. You have workers, in this case painters, and you have time, which in this case is weeks, and how much work can they do. Given 4 painters can paint 6 houses in 14 weeks, how many painters do you suppose 12 could paint 12 houses in 28 weeks? I will reveal to you that most people say the answer is 8, because you double the time, you double the houses, so you double the painters, and that is completely, unfortunately, false. Why? Because in 14 weeks, these 4 painters can paint 6 houses, and in the next 14 weeks, the same 4 painters can paint another 6 houses for 12, and that means the answer to this is 4. Wow. I'm going to talk about a very powerful and accessible technique to work tricky problems like this. If 6 painters can paint 7 houses in 24 days at that rate, how many houses can 18 painters paint in 72 days? Well, it looks like you got 3 times 6 is 18. You got 3 times 24 is 72. So should the answer be 3 times 7, which is 21? And the answer is no. Because why? Because if you triple the painters, that will triple the houses painted all by itself. And if you further triple the time, that's going to multiply it by 3 again. So this answer is going to actually be not 3 times 7, but 9 times 7. Here's what we're going to rely on, and that is that the workers times the time is directly proportional to the amount of work that can be done. In real life, it's not always true, but we are going to make that assumption so that we can make some of our calculations to estimate how much it's going to take. So in this case, 18 painters, 72 days, that's called painter days. Sometimes they call things like this man hours or man weeks, but you know, women work harder than men often. So the number of painters is 18, and the number of days they're going to work is 72. And how many houses can they paint? I don't know. But whatever it is, it's going to be part of a proportion where you have 6 times 24 divided by 7, because that is the standard. It's given that 6 painters can paint 7 houses in 24 days. Now, 6 times 24 is 144. Any combination, we'll stick with whole numbers, but any combination of 6 painters and 24 days, 6 times 24, any combination of numbers that multiply to 124 would work. For example, 12 times 12. 12 painters, 12 days, they will paint 7 houses. You could have 2 painters in 72 days. 2 times 72 is 144. Or one painter working for 144 days can paint 7 houses. So that's how this works. And it's the problem at hand is you have 18 times 72 and X number of houses. But the 1296 is the worker time, and the 144 is the worker time to paint 7 houses. This is going to paint X number of houses based upon that standard. So again, our easy proportion is 1296 over X equals 144 over 7. And now we're free to go home here because we know how to do this. You find X, its partner is 144. The other two multiplies 1296 times 7. You don't actually have to multiply that out. You can just put on your calculator 7 times 1296 divided by 144. That turns out to be 63. This is on page 28 of your book. You can verify that. Now, intuitively, if we multiply both the number of painters and the number of working days by 3, that will multiply the number of houses by a factor of 9, which is what I said earlier. All right, here are some numbers that are less friendly. Let's say that 6 crews of pipe layers can lay 14.3 miles of pipe in 79 days. So 6 crews of pipe layers, 79 days. So that's workers times time. They can lay 14.3 miles of pipe. Now we have 120 days and 53.5 miles of pipe. So how many crews do we need? Oh, well, let's see. 120 times X crews equal 120X over 53.5 would have to equal 6 times 79 over 14.3. Workers times time divided by work is a constant. So we find X and its partner. So this is going to be 14.3 times 120 equals 53.5 times 6 times 79. Now, here's the cool part of this from a calculation point of view. You don't actually have to write out the answer to the right-hand side, just 53.5. Be sure you punch in the right numbers, times 6, and then times 79. And the order doesn't matter. Multiply those 3 numbers in any order you want. Now, I'm going to divide by 14.3 times 120. I don't even have to know what 14.3 times 120 is. I can divide it by either one of these numbers, followed by dividing by the other. I will divide it by 14.3. Don't forget to look at it. And then I will divide that by 120 right here. That's going to give me 14.779, which to 2 decimal places is 14.78. So remember, the order doesn't matter. If you're going to divide by 14.3 times 120, you could instead divide by these 2 things one after the other. If you have a scientific calculator, of course, you can put it all in parentheses. Now, when you get an answer like 14.78, if it's like people, well, that's for planning purposes only. In real life, you may want to count on 15 crews or maybe 16 or 17, depending on what the weather looks like. So here we have on page 30, this is the page you're going to use that's going to help you enormously to get a better grade, get a good grade. So we got workers, in this case it's painters, and time is in weeks, and W is the number of houses that P painters can paint in T weeks. The standard is 4 painters can paint 6 houses in 10 weeks. But any combination of 4 times 10, any combination of 40, it could be 2 painters in 20 weeks, 1 painter in 40 weeks, 5 painters in 8 weeks. Any combination of 2 numbers that multiply to 40 will give you the same exact formula. You're going to use this standard to find out the value of any one of these unknowns. Let's start off with P. So this one would be phrased like this. How many painters are required to paint 19 houses in 23 weeks? Well, workers is P, weeks is 23. So P times 23, that's 23P over 19. must equal 4 times 10 over 6. Oh, because the amount of work is directly proportional to the workers times the time. Now we cross multiply. 6 times 23p must equal 40 times 19. I can divide both sides. I can divide 40 times 19 by 6 and then divide by 23, or I can multiply them if I want to. It's shorter if you just don't. Just say 40 times 19 divided by 6 divided by 23. Show you that on here. How many houses can 9 painters paint in 7 weeks? Well, let's see. 9 times 7 over W. Now, you always go back to the top. This is the standard. Do not use the results of problem 1 to work problem 2. It would work, but because we're rounding off, we're going to have an error that keeps accumulating larger and larger the more problems we work. So 9 times 7 over W must equal 4 times 10 over 6. And this is so easy as wrote 63, but you don't have to. You can just put 6 times 63 or 6 times 9 times 7, doesn't matter. 40W equals 6 times 63. Divide that by both sides by 40, you get 9.45. Comes out even, and we're happy. So how long will it take 15 painters to paint 13 houses? In this case, time is unknown, but workers times time, 15T over 13 must equal, guess what, 40 over 6. So now we cross multiply. We find T and its partner. So 6 times 15T must equal 13 times 40 or 40 times 13. Now, I would just look at this guy right here. Say, okay, look, let's just do that on the calculator one more time. 40 times 13. And whatever that is, I'm going to divide it by 15. And I don't have to write the 520, but I can. And there's the 34.66. And that, of course, is incorrect. Why? Oh, yeah, here it is. Sorry, my bad. 40 times 13 divided by 6 divided by 15. And there it is, 5.78. I divided it by 15, but I failed to divide it by 6, so my bad. Well, there's my mistake.